helps in two ways. First, it'll help across the whole project lifecycle, so from concept study all the way through to closure. And then once you're in operation from a day-to-day perspective, it helps in the execution mode and determining whether you're going to meet your targets. So if we look at the project lifecycle, when you're looking at the concept study stage and you're doing that options analysis to then be able to go and get funding for a detailed study, you'll be looking at a lot of those ESG elements around emissions, around energy usage, around how am I going to produce my power, where's my water coming from, dewatering. There's a whole tranche of regulatory type options that end up driving the cost and the feasibility of the project. So certainly at that high level study where we're looking at that strategy, that longer term time frame, that life of the project, the simulation helps there in terms of setting up the project for success. So you define a project outcome that is going to achieve your revenue targets, and you're really clear on what you're achieving from an ESG perspective. You've really set your limits there from that ESG perspective, and that then enables you to have your project set up for success. Once you've got that money for the next stage of study, you then move into that next level of detail. So then it's coming up around detailed equipment selection. It's coming up around the method you're going to use for your power generation. It's coming up around exactly how much water, what your quality of your water is going to be. So the regulators have a much higher level of requirements and approvals that they're going to want to carry out at that stage. So you really need to be able to meet those requirements. And when you get down into the detail of equipment selection, you really then need to be able to carry out those trade-off decisions, because you're looking at the performance of the equipment against the capital and operating cost of the equipment, potentially its energy usage, and therefore those ESG type elements. You've really looked and moved from those high-level requirements where you've made the decision that the project can go forward and refine in a bit more detail. You're now really unpacking, what am I going to build? Because I'm basically going to go and get money for what I build. And then I need a different level of detail, because the regulators are really going to want to approve things at a much higher level of granularity. I'm going to need to be making decisions on the type of power, the size of the power station, where it's located, where I'm going to be pumping the water to. So I need to be able to define those limits, so when I go and get my final approval for money and I go and build my project, that I understand all of that and it will actually deliver my commitments. Because if I don't, they're going to have some challenges around my continuing operation of the project. Once I've actually built what I've had funded, I then need to operate. I need to execute it. I need to make sure that I'm going to meet those targets. I need to do what I said I was going to do in the study. And really that's when the level 3 detailed model helps with that, because it is running the simulations and looking ahead. It's really looking at the horizon to assess what my performance is going to be and whether I'm going to meet the limits that I've set with the regulators around those targets, as well as the commitments I've made in many cases on publicly listed. So I've made commitments to the community, to the government, and there's a set of expectations around how I'm going to perform with respect to those key ESG measures. So I need to understand where I'm going to vary from that plan and how I'll recover back to that plan. Because breaches on paper for a study, not much of an impact, quite cheap to fix. Breaches in reality, in real life, executing, a lot more serious, a lot more disruptive, a lot more expensive to fix. So I really don't want to be hitting those breaches there. So having that model that I've slowly fleshed out in detail over time, from feasibility of the project, optimizing what I build, and then optimizing my execution becomes really, really critical. And then as I move through to closure and I'm looking to, rehabilitate, I'm looking to shut the operation down, got certain commitments I need to meet there with respect to, emissions, power, rehabilitation, water usage and the like, community impact, noise, the list goes on. The combination of those factors and my ability to meet my commitments there become really important. So simulation, again, coming into that is really important. And it really comes back to the discussion earlier for complexity, the number of factors that we need to consider now. And ESG just brings in a whole tranche of additional variables means that the key drivers and the view of how I'm going to achieve my target, and even thinking about will I meet my target and am I going to breach, just becomes so much more difficult. So the tools and the simulation actually help us be informed, to make those informed decisions at that time so that we can move forward and get through that whole project life cycle. In terms of maybe a clarifying example in the execution space, if we think about an underground mine that's operating electric vehicles, one of the key challenges we've got is that those electric vehicles need to be charged, so they're running on batteries. At the moment with the technology, an electric vehicle will struggle to get from the bottom of the decline at the mine up to the surface without at least a recharge or a battery swap. What that really means is I need to look at where I locate battery charging stations, battery changeout stations, or how I'm actually going to physically operate electric vehicles differently to the diesel vehicles. So in that operating mode, I'll have detailed models about how quickly my batteries will deplete, where I need to recharge them, what's the minimal impact I can have. So I'm really going to be thinking about where my battery charge out stations are and how I minimize the impact of needing to operate with those batteries. So if I think about it from the perspective of operating in that electric environment, batteries have a requirement for recharging that with the current technology is very different to the life cycle for, say, refueling a diesel truck. I need to be able to understand how that is going to work on a day-to-day basis. Where am I best to locate my charging stations? Am I better to have charging stations or battery change-out stations? Even if I have battery change-out stations, I'm going to have to transport charged batteries from somewhere. So there's a lot of logistics that come into play that are in addition to what I would see in a diesel operation. So it's really about staying on top of the performance there and making sure that I'm going to have as smooth a production day as I can. So that's really where simulation at the next level is going. Many people will refer to those as digital twins. I'm sort of a bit 50-50 on the expression digital twin. I think it's a simulation that sits next to an operation and informs you, provides you with information and context about problems that may occur. If you want to call that a digital twin, fine. But for me, it's really just a guide to sit there and help you with things that may happen, let you run the what ifs, and really give you the best chance of hitting your plan through the course of your shift.